Okay, so now we're moving on to a pedigree. So a couple things about a pedigree are males and females and affected versus unaffected. So a circle represents a female and a square is a male. If it's shaded in, so shading means that they're affected, they have the disease or disorder, and open or just clear represents unaffected. So we have two types of inheritance that you'll have to deal with on a pedigree. Is it recessively inherited, or is it a dominant type of inheritance? And again, the difference between the two is you have to have two recessive alleles to express the phenotype if it's a recessively inherited trait. If it's a dominantly inherited trait, then you only need one dominant allele. So a really easy way to tell when you're looking at a pedigree if it's dominant or recessive is if you see a very low number of affected people relative to all the people in the pedigree, it's likely going to be a recessive trait because you would have to have two recessive alleles in order to be affected. For a dominantly inherited trait, because you only need one dominant allele in order to be affected, you will see a higher proportion of the individuals in the pedigree who are shaded in, meaning that they're affected. So looking at this is going to be a recessively inherited trait. There's several people in here and I only see 3 affected ones. So your job on a pedigree is to, 1, determine is it recessive or dominantly inherited, and 2, to go in and fill in the genotypes for every person in the pedigree. So I always like to start at the bottom. And in my pedigrees that you're dealing with, it's not even going to give you what the disease or disorder is that's causing it to be affected. So you can pick whatever letter representation that you want. Again, we're working with dominantly and recessively inherited things, so we're just going to pick one letter, and we're going to use a capital letter to indicate that it's dominant and a lowercase to indicate a recessive allele. So I'm going to pick one that doesn't look similar when it's capital and lowercase, so I'm going to pick R. So because all of our affected individuals, we're assuming that this is recessively inherited because we have a low population in the pedigree. Another way to tell that you're dealing with a recessively inherited trait is that unaffected parents can have an affected offspring. Other things about a pedigree, which I probably failed to mention, is the line that's connecting a circle and a square represents a union. I'm not going to say marriage, in which point they had these 3 offspring. So they look like they had all boys, that poor mom. And then this particular offspring, this open square, had a union with this affected female, and they went on to have 3 girls. Oh man, that poor mom. Okay, so again, your goal is to determine what the genotypes are for each of these individuals. So I start with the affected, and then I usually work from the bottom up. That's just how my brain works, but you can work from the top down. That's totally up to you. So we've determined it's recessively inherited, so I'm going to designate everybody who's affected with 2 recessive alleles, which means it's recessively inherited. Okay, so I'm starting at the bottom. We know that this, the father of these 3 girls right here, he has to have one dominant allele because he's not affected, okay? So do these other 2 daughters here. They're unaffected, they have to have a dominant allele. Well, looking at this affected child right here who has 2 recessive alleles, they couldn't have gotten both from the affected mom up here. Remember, the alleles for offspring, one had to come from mom and one had to come from dad. So that means the dad's other allele had to be recessive if they had an offspring with 2 recessive alleles. Okay, looking at the other 2 offspring, they have a dominant allele because they are unaffected and we don't see any shading. The only parent who was able to donate this was dad, which means that the affected mom had to give them a recessive allele. So we were able to determine at least this portion genotypes. Okay, so now let's move on. Same thing here. We have this son who had 2 recessive alleles, which means he had to get 1 recessive allele from mom, 1 from dad. Dad and mom are not affected, so they have to have at least a dominant allele as well. Okay, so now moving on to the only person left is this son right here. They're unaffected, so they have to have a dominant allele, but this is where we really can't tell what the second allele is. Because say this parent donated a dominant allele, they could have either gotten another dominant allele from the mom and still would have been unaffected, or got a recessive allele from mom and would have been unaffected. So how we actually indicate this one that we're not entirely sure what the second allele is you put an underscore. So we can, for certain, provide the genotypes for every other individual in the pedigree, except for this person here, which is okay. We know they have at least 1 dominant allele because they're not affected, and we're just going to write an underscore underneath for their genotype.